this is just part of what we were covering in the past about engineering misconceptions, and now this part deals with what different measures of engineering deal with, and we start with mechanical. And what you'll see in mechanical is that they are more in machines, production, and manufacturing. And so, therefore, you in mechanical engineering, you find them dealing with the design of machines and how different parts of machines relate with each other, how they make the work feasible, and therefore, that is so. What you'll find in mechanical engineering is that people who are dealing with machines and the manufacturing, and therefore, and you find them drawing diagrams of how the machines is assembled, etc. So that is what mechanical engineering involves, and therefore, again, in mechanical engineering, you'll find them designing systems, how well they move, and this involves analysis and design. So when you get the cars of today, they are always made to avoid air friction, and therefore there is some aerodynamic design of vehicles that always considered, and that is normally the work of engineers, and that again cuts across as well in the aeroplane industry, whereby you see that the design of airplanes or aeroplanes is such that it minimizes the friction with the air, and therefore the gadget that is moving is designed to move with speed, with minimal resistance. So again, in mechanical engineering, they deal with the design of such systems like the vanes that are used for generating with energy. And again, you find them designing fuel cells. As much as this might also cut across in electrical, you also find that it is part of mechanical engineering. So again, in mechanical engineering, we will still find them designing the space shuttles, how they are going to sustain themselves in space, but despite consuming energy, carrying fuels, etc. And therefore, this is UAV, unmanned aerial vehicle. Again, you find drones falls under this category, and we have said in the past that drones it actually falls under the category which you might see under mechanical, because we are talking about flying objects. It is under the category of airplanes. Then it also falls under the category of mechatronics, because they are in this category. We are saying that it is unmanned, so it is more like a robot, and therefore the robotic aspects are going to be considered. And again, it is still falls under the electrical and electronic engineering, because there are electrical components involved, and there is supply of power, management of power, and instructions that are given, communication, etc. So this initially may appear to be in mechanical engineering, but it's still find it in electrical and mechatronics. So again, in mechanical engineering, you still find them dealing with utilities. This might be power generation, because power generation, like geothermal, they deal with how the hot air is carried, hot air or steam is carried, and therefore the systems that carry the hot air or the hot steam are designed by mechanical engineers. Electrical engineering do only deal with generation of electrical of power when it has now reached the level of turning the turbine. But how that air is carried is actually the work of mechanical engineers. But again, also in utilities, we find mechanical engineering designing the tubings for carrying waste. So the design of these tubings and their mechanical strength is actually falls under the category of mechanical engineering. So again, we also say that robotics sometimes is classified under mechanical engineering. So designing robots, and there are so many robots today that are useful. I don't want to dwell there over much, and we want to just have a highlight of what civil engineering come up with. We also say that civil engineering deals with the foundation of houses or buildings. So when you see a skyscraper, talk about skyscraper, skyscraper. That is another word for very tall buildings. So that there is some analysis, particularly of soil, must be carried out by civil engineers, and then they design what kind of foundation, that is the strength, the depth, among others, that on which this skyscraper is going to be standing on, and therefore that work falls under the category of civil engineer. And I have said in the past quite often that this skyscraper will have structures. We talk about beams on which it stands, and therefore these beams are the ones that are illustrated by this diagram that is not very visible. They do so many mathematics in terms of how much weight can it withstand. If there is some force from the side or at an angle, we need to be able to withstand how much maximum we need to withstand, etc. So all those mathematics falls under the category of structural analysis that is carried out by civil engineering. Again, we have already talked about this skyscraper design. While the initial work is done by an architect, the background architect, the architect might come up with a very beautiful design. Actually, the aesthetic design is dealt with by the architect. So the architect will tell you that you need to have proper lighting, how people are how the building is going to be accessed, among others. But when now the architect has come up with that beautiful design, then it is the work of a civil engineer now to design the structure itself, the beams, the foundation, etc. That I have said in the past, and probably I'm just repeating myself, but nevertheless it's important to understand how or where the civil engineering falls in. And we must understand the interrelationship between different engineering professions. So we have gone through mechanical, we are going through civil engineering now. And in the civil engineering, we are talking about bridges, and we have seen bridges, and the text that I have just shared with you really discusses these concepts in detail. The bridges, so they are crossing over the water bodies or mountainous regions. So we create bridges, and again, tunnel is now, these are the ones that go under, and still this needs require to be supported. So what you might observe is that under the tunnel, there is a structure that is built so that this tunnel does not cave in, okay? Ordinarily, because of the weight of the earth on top of the tunnel, there is likelihood that if it is not properly supported, it might cave in. And therefore, to stop that, there is some design work that is carried again by civil engineer. Yeah, and I talked about environmental division of civil engineering. So sometimes today you might have people who call themselves environmental engineers, but their mother profession must have been civil engineering, because it is in the civil engineering that aspects of water treatment, sewer lines, water conservation, among others, all those systems that treat water and manage sewer lines are managed or designed by civil engineer, and therefore that again falls under the category of the design of civil engineering. Again, in civil engineering, you also find transportation systems, how roads are built, their strength. Sometimes someone might think that a road is just built by some people who might not be as qualified, but it should be very clear to you that roads carry life, and anything that carries life must be designed with precision. So we don't just, because sometimes you have had probably in Kenya we have had a region called Mahio, in which case we have had ground opening up such that this is the ground. You get a valley. I don't know which is the correct word to use. This like earth separating because of the Rift Valley aspect of earth movement or eruptions that might have volcanic activities that might characterize that region. It causes the earth to separate, and therefore you have heard that while the road was passing through this region, it cracked. And therefore, that kind of analysis on the suitability of the earth or the ground to support the road, it is done by civil engineers. And again, still civil engineering are concerned with design of utilities. That is, I know you have seen these lines, in which case where I have said that they are used to carry high power lines or high voltage high voltage lines, and we call them pylons. I think I have said that in our past lecture. So this design of this structure to carry our electrical lines is normally done by a civil engineer, because they normally carry heavy, they get heavy, they reach over long distances, and therefore they require to be designed with proper knowledge. And now we jump to electrical engineering, in which case we discuss different aspects of electrical engineering that we design. And we have said that engineers are going to be designing, again, the transmission lines. This is what we call them. They carry very high voltage, probably 130 kilovolts. The normal voltage that you work with every day that is supplied by AC is about 240 volts alternating current. And sometimes the one that powers your phone is a DC current that is normally converted from AC by an adapter. This adapter gives you an output of 5 volts, and therefore your phone consumes very little voltage. But all this comes from all these transmission lines that are carrying high voltage lines, and the high voltage is transmitted on purpose, because at high voltages, as you observe in your advanced level of electrical engineering, you observe that there is low power loss when the voltage is transmitted at high voltage. And therefore, what happens is that at the generator station, probably it might be the power might be generated at approximately about 1,000 volts, etc. And therefore, but when it is getting transmitted, it is transformed to a higher voltage of about 130, 120, etc. for transmission. And therefore, that is what electrical engineering does. It is one of the aspects that engineering deals with. And then we talked about electronics, where we normally design circuit boards. And I guess you might have opened your laptop, your phone, in the bucket there are such boards, a radio, among many others. So these are the electronics that constitutes most of the electronic gadgets, and this is called a motherboard. A motherboard is built by electrical engineers, and each of different components performs different tasks, but at the end of the day, they performs one role for which the system is designed. Moving forward, I think we have talked about this, and therefore the other aspects that engineering, or the products that engineering produces or designs, we have said in the past, is a motor. A motor is used to so if you have not seen a motor, I will give you a very straightforward example. Posho mill has a motor that rotates, probably powered by a diesel or electricity. So this rotates, and therefore it rotates. It is connected with now some grinding machine. That grinding machine is the one where you put maize here, and so the posho mill mixes or grinds from maize to flour. So it is turned by a motor. So the design of that motor is the work of an engineer. And again, sawmill also has motors. It has some machine on which it is rotated by the motor, as long as the motor is powered, and the motor produces timber from wood. So again, those are very basic examples, but engineers ideally will come up with the design and manufacture of such. Yeah, and again, the generator. The generator falls under the category, it's again designed by electrical engineers. The generator converts, I think, chemical energy, but it is just one of them. Diesel can convert diesel or mechanical energy, like dam water to the one that we call potential energy, rotates turbines, and then produces electricity. So this is a small version of a generator, but again, the generators that runs in hydroelectric power plants, they are still called generators, and they produce power. So they convert either of these forms of power, either diesel, water that is in potential, having high potential to produce electrical energy. Okay, and again, electrical engineers still design instruments like power supply. So power supply, this is a device that you find in your lab. lab, and this like generates different power values, or you might require some 12 volts or some 5 volts with different currents, etc. That kind of power supply is designed and produced or manufactured by electrical engineers. Again, another instrument that you find in our labs is the oscilloscope. Oscilloscope is used for measuring signals, such that you might have a signal received. And again, the straightforward one is your phone or radio receives radio signals or radio waves. And those radio waves can be received by a receiver, by an antenna. And now once the antenna has received, it will convert this one to electrical currents or voltage. And therefore, this can now be measured by an oscilloscope. And now it will give you a sinusoidal or other kind of signals over which that have been received by the antenna. So again, that is a product that electrical engineering are always dealing with. Again, in electrical engineering, we are always measuring values, we are measuring power, we are measuring current, we are measuring very many aspects of engineering, and therefore we normally design measurement to devices like digital or analog meters. So if you want to find out how much voltage my battery is holding, I will always use this kind of meters to guide me. Of course, give me the accurate measurement. So again, and I think I have said over and over again, communication is a huge branch of electrical engineering that falls under the category of telecommunication engineering. And I have said in the past that our telecommunication engineers like deal hugely with communication aspect of electrical engineering. Telecommunication will not deal with power generation, etc., but they are going to be dealing with how signals are sent, etc. So you can see that here we have a radar or a big antenna, and how they communicate, particularly when you're talking about an aeroplane that is requires to land. It requires to communicate with the station. So there is a need to communicate with on the ground, and probably even communicate how far you are, how is the ground, is it possible to land, etc. So that kind of communication systems are called radar. They allow communication with devices from air, and that is a big category or a big field in electrical engineering. And this is another kind of antenna that still is used. So under the category of radar, we have these kinds of antenna you are going to be learning about and designing. So the last, I guess, we almost the last one. We have been talking about these gadgets, the mobile phone, how they communicate. Computer science born from electrical engineering. Before the computer systems became quite common. This was purely done by electrical engineers under the category of telecommunication engineers. But as the issues arose, and particularly for networking, etc., there came a small sub-branch called computer science that deals with the communication systems under the computer system. And therefore, you might not learn in detail about how computers work, because it is dealt more on by computer scientists and IT experts or IT students who are studying IT. But again, this falls still under the category of telecommunication engineering. So this is a summary of many majors that you can find in electrical engineers that either support electrical engineers or the engineering majors that are different and support one another. None can depend on itself alone, and therefore you will find that they are integrated in a many way, and that is what we have been talking about in this lecture and in the previous lecture. And this is more of a summary of what you might find. Even there are others that are not here, but nevertheless, you can always plug them in. Nobody will ask you to list all of them. You only need to know that such and such major exists.